So let's take a look at what a particle motion problem looks like in calculus and how we're going to tackle it. So here we have that the velocity of a particle that is moving along the x-axis is given by the function the velocity in terms of time is equal to 3t squared plus 6. They say this is a non-calculator active question, which means we should be prepared to solve it without using a graphing calculator. All right, so if the position of the particle at time equals 4 is equal to 72, then what is the position when t is equal to 2? All right, and we've got these three things to keep in mind up here at the top of the page. So which one of these do you think applies to this problem? Well, we know here that p of 4 is equal to 72, and we know the velocity, and we want to know the position at a different time. So that looks like we could use the fundamental theorem of calculus up here. All right, so we've got the integral from what two times are we interested in here? Well, we know about the time equals 4, and we want to know about the time equals 2. So let's do the definite integral from 2 to 4 of v of t dt, and that's equal to p of 4 minus p of 2. All right, so v of t we know, they tell us that that is equal to 3t squared plus 6 dt. It's equal to p of 4, 72 minus p of 2. So since this is a non-calculator active question, we need to calculate the antiderivative of this function so that we can evaluate it. So this is just a polynomial, so we'll just use the product rule, except in reverse. So the antiderivative of 3t squared is t cubed. The antiderivative of 6 is 6t. We're going to evaluate that from 4 to 2, and that's equal to 72 minus p of 2. So calculating this, it's just going to be 4 cubed plus 6 times 4 minus 2 cubed plus 6 times 2. And that's equal to 72 minus p of 2. All right, so 4 cubed is 16 times 4, which is 64, plus 24, minus 2 squared is 4, plus 12 is equal to 72 minus p of 2. 64 plus 24 is 88, minus 4 plus 12 is 16. So that's 72 is equal to 72 minus p of 2. So let's subtract 72 from both sides of this equation. So we've got 0 is equal to negative p of 2. And so that means that p of 2 itself is just equal to 0. All right, so at time equals 2, the particle was right at the origin, as it turns out. Okay, so let's stop there. And then in the next problem, in the next video, we'll take a look at the second part of this problem, where they're asking us to calculate the distance the particle traveled. So we're going to be using other rules from up on the top of that list.